But to understand how we can find the best value, the maximum value, we need to do some mathematics. So here comes a mathematical intermezzo, and what we're going to do here is we're going to determine the maximum value of L over D. How do we do that? Well, first we need to understand that there is a direct relationship between the lift over drag ratio and the ratio of CL over CD, the values for lift coefficient and drag coefficient. That comes purely from the definition of the lift coefficient and the drag coefficient, because the equations say lift equals the lift coefficient CL times half rho V squared, the dynamic pressure, multiplied by the wing surface area S. And an equivalent expression holds for the drag coefficient. So looking at L over D is exactly the same as looking at CL over CD. So if we want to maximize L over D, it's equivalent to maximizing CL over CD. And more importantly, it is equivalent to finding the minimum value of CD over CL. It's mathematically totally the same. And it proves to be a bit more handy in our case. So what we're going to do is we're going to minimize CL over CD. How do we do that? Well, that's pretty straightforward. You take the derivative of that expression of CD over CL and equate that to 0. So what we're going to do, we're going to take the derivative of CD over CL with respect to the independent variable CL. CL is my independent variable in this case, and we're going to equate that to 0. So let's start with the expression of the drag polar again, and then divide that by CL to find the expression for CD over CL, and then find 0.1035 over CL plus 0.0432 times CL. And then I need to take the derivative of that with respect to the independent parameter CL. And then this becomes minus 0.1035 over CL squared plus 0.0432. And we need to equate that to 0. And that's pretty straightforward because we have one equation with one unknown, and we can solve that. We can solve that one for CL. If I do so, then find that my value for CL is 0.559, and plugging that value into the expression for the drag coefficient, I find that the value of my drag coefficient is 0.0270. Then I can divide the two, and I find my maximum value for CL over CD, and thus the maximum value for L over D, and it's 20.70, almost 21. And that's to be expected because the aircraft has nice slender wings, so you expect a relatively high lift over drag ratio. Putting this in the graph, you see the following. The red dot is the point where you find the maximum value of CL over CD. Could we have found that without all the mathematics? Yes, we could. What you should have done to find that is to draw a tangent line to that curve, to the drag polar, and then the point where the tangent touches and the curve touches the graph, we have the point of maximum lift to drag ratio. So we could also done this graphically.